Lesson 16.9. Integrating functions of the form f of ax plus b. From the investigation, we noticed that to take the integral of these functions, we can simply follow the rules that we learned from the last lesson and then divide the result by the coefficient of x in the linear function in the composite. Later on, with more practice and experience, you will not have to rely on this chart at all, and you will know what exactly you have to do. Let's take a look in example 1. Find A. The integral of 4x minus 1 cubed dx. Here the big picture is the cubic function, which means that I can pretend that I'm just integrating a cubic function where I have to increase the exponent by 1 over that same exponent. Because this is a linear composite, consider the coefficient of the x term, which is 4. I need to divide my result by that number, plus c. This gives me 4x minus 1 to the power of 4 over 16 plus c. Question B. Let's integrate 5 sine 2x minus 5 dx. I can pull out the 5 if it's a distraction so that we can focus on the integral of a sine function. We know that when we integrate sine, we get negative cosine. So I get negative 5 cosine of 2x minus 5. Because of the 2x minus 5, I know that I need to divide this by 2 plus c. You could write this as negative 5 over 2 times cos 2x minus 5 plus c as well. Let's take a look at question C. Here we have tangent squared of 1 minus 3x dx. Some of you may be wondering, well, is this a typo? Tangent square, I don't have a rule for that. Well, this is not a typo. So then you have to think a little bit about how we can, rewrite this expression so that we can apply integration rules that we already know. If you recall, if I have tangent square theta, there is a trig identity, secant square theta minus 1, that I can apply here. And theta in this case is 1 minus 3x. So let's rewrite this. I have the integral of secant squared 1 minus 3x minus 1 dx. That's better, right? Because then I know how to integrate secant squared 1 minus 3x dx. I also know how to integrate negative of integral of 1 dx. The first part is tangent 1 minus 3x over negative 3, or I can say this is negative 1 over 3, 10, 1 minus 3x. The integral of negative 1 is negative x plus c. Okay. Let's look at an application question. Example 2. A stone is thrown vertically upward from ground level with a velocity of 20 meters per second. If the acceleration is, let's correct this, is 9.8 meters per second squared down, determine the position time function s of t. So we're going back to relate these kinematics relationship between acceleration, velocity, and position. Let's list what's given to us. We are starting from the ground level. That means we can assume s of 0 is 0 meters, if you want to include units. The initial velocity, v of 0, is given as 20 meters per second. Acceleration, well, it doesn't mention anywhere because it's constant. Okay, so a of t at any time is negative 9.8 meters per second squared. So here we're going to look for s of t. Looks like we can start with the acceleration function and then use that to find the general function for v of t by taking the integral of that with respect to time. This gives negative 9.8 t plus c. Well, I need to know what this c is, so let's apply the idea of v of 0, which is negative 9.8 times 0 plus c. Well, that implies c is equal to 0. As a result, v of t must be negative 9.8 t plus 0 as a function. Now, knowing that v of t is negative 9.8 t plus 20, we can go ahead and look for s of t, which is the integral of negative 9.8 t plus 20 dt. Take the integral of that, negative 9.8 t squared over 2 plus 20t plus d, which simplifies into 4.9 t squared plus 20t plus d. We know that s of 0 is d if I plug in zeros into the t's, which implies that d must be 0 because that was the value of s of 0. Therefore, s of t is the function negative 4.9 t squared plus 20t.